Okay, so we're continuing 5.8, which is solving applications. So last time we talked about what? Was it the Pythagorean theorem? So we're continuing with geometry, number problem, etc. Yeah, okay. But in this case, we will have quadratic equation and we will factor also. So let's continue. Let's share the desktop. Okay. Yes. So we were here yesterday. We had Pythagorean theorem. Thursday. Yes, last time. So homework up to 5.7 were due, right? Okay, good. Now the second one. So A was Pythagorean theorem. Okay, for right triangles. B, let's talk about the applications involving numbers. So, applications involving numbers. All right. So, this is number one. A number is 6 less than its square. Find all such numbers. All right. So a number is 6 less than its square. So how would I write that down? What is a number? Yeah, but what is x? X is a number. What about its square? No. X. What is the square of the number? It's x squared, right? Good. Step 2, none, because we're not drawing and we don't have a table. Step 3, what is the equation? A number, so x is equal to 6 less than its square. So what do we mean by 6 less than its square? X squared minus 6. Yes. Can we solve it? Yes. How? Standard form? Okay. So x squared minus x minus 6 is equal to 0. So is it factorable? What is it? X minus 3, x plus 2. Yes. So x is equal to 3. Oh, this is step 4. When we solve, this is step 4. X is equal to 3 or x is equal to negative 2. Good. That's it. Done. Continue? Oh, what are the numbers? Sorry. We have to write down the answer. The numbers are both correct? Yes, 3 and negative 2. So there is no restriction. It doesn't have to be positive. It doesn't have to be negative. So you have 2 of them. Okay? Now, number 2. This is page numbers. So the product of the page numbers, is this easy for number 1? Oh, what did I do? The product of the page numbers on 2 facing pages is 420. Find the page numbers. When you say facing pages, okay, so give me the two facing pages. What are the pages? Facing pages. So if one page is 30, what's the other page? 31. So what about if it is 50? 51. So you know X is the first page. What is the second page? Yes, that's right. So X is the first page number. What about the second? Yes, X plus 1. So this is the panel, so it means just copy the top. Yeah, it's quick writing. The second page number. Step 2, none. Step 3, what about the equation? The product of the facing page number is 420. So how am I going to do it? The product, what is the product? Multiplication. So what is this? X times X plus 1 is equal to 420. Right. So X squared plus X minus 420 is equal to 0. Is it factorable? It's a little bit hard, right? Because the number's big. So let's see. So it's probably almost close to the middle. So maybe, because when you say 420, then you start with 1 and 420. Look at these. How are you going to get 1? So it's probably big. Let's just say 10 and what? 10 and 42. Will you get 1? No, maybe not, right? 10, 11, 12, 13, 14, 15, 20 maybe? 20. What is 420 divided by 20? 21. Will it give you 1? Yes. So this is negative 20 and positive 1. Positive 21. So X minus 20 times X plus 21. All right. Equals 0. Remember, equals 0 because you need to solve it. So what is X here? 20, or X is equal to negative 21. So which one? Is it the 20 or negative 21 or both? Which one do we choose? 20? Yes. Why is it 20? Page number cannot be negative. Yeah, so this is not, right? Page number cannot be negative. So what are the first page and what are the second page? The first page is 20. How about the second page? Yeah. Is it easy? Okay. All right. Good. I am done with the applications involving numbers. So the next one is geometric applications. Yeah. So C. So we talk about Pythagorean theorem, and then this is applications involving numbers, and the next one is geometric applications involving geometry. So C. Application involving geometry. All right. Let's see, geometry. Okay. So it says here, so number 1. It talks about the work surface of Anita's desk. So the work surface of Anita's desk is a rectangle that is twice as long as it is wide. Okay. So if the area of the desktop is 18 feet square, find the length and the width. So, let's read this again. So, the work surface of Anita's desk is a rectangle that is twice as long as it is wide. So, what does it mean? Twice as long as it is wide, what does it mean? 2 times? And then the area is 18 feet square. What is the length and the width? So, can you imagine her desk? What happened to the desk? Is it longer or wider? Longer. How much longer? Twice. Yes. So let's see this. So step 1, step 2. Now we could draw, right? We could draw the desk surface, the surface of the desk. Okay. Then how would you label this? This is X. What about the other one? 2x. Why is it 2x? Yes, because it is twice as long, yes? So, that's why. X and 2x. Right. So, which one is the width? X is the width. What about the length? Alright. Good. What else do we know about the perimeter? The rectangle. The area is 18 feet square. Okay, good. Now we could combine our knowledge. We know the area. So what's my equation? What is it? 2x squared is equal to 18. So length times width. So remember, for area, the formula is length times width is equal to 18 feet square. What is the length? 2x times x is equal to 18. So 2x squared is equal to 18. What is x squared? Do you want to bring it to one side? Yes, let's do it in standard form. 2x squared minus 18 is equal to 0. So standard form. Okay. Then what? Divide by 2. So you have x squared minus 9 is 0. Is it factorable? Yes. Oh, by the way, this is step 4, right? And we solve. How do we solve it? X plus 3, x minus 3? Okay, so x is equal to -3 or x is equal to 3. Which one do we take? Which one do we take? Positive 3? All right. Why not negative? So this is not y. Because width cannot be negative. All right. Good. Now, what is the length? So we have to answer the question. So the width is, and the length is, okay, so what is the width and what is the length? 3 what? Feet, okay, and the length is 6 feet. Why is it 6 feet? Yeah, so this is your x, this is your 2x. So we actually go back to the first definition here. Yeah, so one is x, the other one is 2x. All right, easy? Okay, now this one is a little bit more. The dimensions of a triangle. What is the formula for the area of a triangle? 1/2 base times, yes, so you remember that, right? Okay. So the second one, we'll talk about the triangle. This is rectangle, yeah? And the second one's triangle, and then we just substitute the value. So actually we're done. So it's good we have a test on Wednesday. Yes, right. It's 2 times the width. So yeah, you know the width is 3, so the length is 2 times the width. Yeah, so 2x. So x is 3. What is 2x? 2x is 6. Yes, good. All right. The next one is dimension of triangle. So number 2. So the height of a triangle is 3 inches less than the length of the base. So it's better if we draw. So the height of the triangle is 3 inches less than the length of the base. Okay? So if the area of the triangle is 54 inches square, find the height and the length of the base. All right. Let's think about this for a while. So what do we know here? The height of a triangle is 3 inches less than the length of the base. If the area is 54 inches square, find the height and the length of the base. So do we need drawings here, do you think? Yeah, we're going to draw. So we will draw a triangle. Oh, this is an isosceles. No. I'd rather draw a regular triangle. Yeah. So this is any triangle. It doesn't have to be special. It's not vertical. It's not, what is it called? Right triangle. Yeah, this is a triangle. So let's see. What do we know? Which one is the height? If I need to draw the height, which one would that be? From where? From the top, and it's perpendicular to the base. That's your height. All right. Okay, so this is your base. And this is your height. All right, so what do you know about the height and the base?
Height is
3 inches less. That's right. So what do you want to call the base? X minus 3? Okay. Or you want B? B minus 3? Yeah. Yeah. So what is B? B is the base, length of the base, right? The length of the base. What about h? What about b minus 3? That is the height. All right. Good. Now, what else do we know about this triangle? The area, which is 54 inches square. Correct. Good. Step 3, where is my equation here? What is my equation? So, what's the formula of area? So, area is equal to 1/2 times base times height. Do we know the area? 54. Do we know the base? B. Do we know the height? B minus 3? All right. Good. Now, how are we going to solve this? Multiply by 2? Yes. So, multiply this by 2. Multiply this by 2. Right? Okay. So, 108 is equal to B times B minus 3. So 108 is b squared minus 3b. So 0 is b squared minus 3b minus 108. Oh, so we're going to try to factor this. 108 is pretty big. So what is this? 108, 1 times 108 doesn't work, right? 2 times 54 doesn't work. What about this? This is divisible by 3. What is 108 divided by 3? 96? No. 36? Okay. Does it work? No, right? What about, is it divisible by 6? 6 times, is it 6 times 18? 18? Doesn't work, right? Now, how about divisible by 9? 12, would it work? Yes? Okay. So you have to try. Remember how I try it? So you have to try, yeah? 9 and negative 12, correct? B plus 9, B minus 12 equals 0. So what is B? 9 or negative 9? Negative 9. Or B is 12. Right. So this is step 4. B is equal to negative 9 or B is equal to 12? Which one do I take? 12. Why not? Why not the negative 9? Base cannot be negative. All right. Yes? It depends on what it is. If we're talking about numbers, it can be negative. But when we talk about length, distance, width, no, right? Yes. If you're talking about the product of two numbers is 23 or something, we're talking about numbers. Numbers can be positive or negative, right? Okay. So it depends on the context. Now, step 5. Do we know the base and the height? So base. What is the base? Because we need to know the base. The base is 12 what? Inches. What about the height? What do we say in the beginning? What about the height? Yes, it's base minus 3. So you know your base. Don't you know your base? This is your base. You know your B. The height would be B minus 3, which is 9 inches. Does that make sense? So I'm looking at these. I'm looking at the beginning. All right. Let's see what else. The application, because I think there is one that is just substituting the values. Do you want to do one more on the rectangle or triangle? One more? One more? Okay. Alright. Let me see. So let's do the road design. Okay. So now, number 3. Is there anything else that is interesting? Not really. Okay, yeah, not really yet. Okay, so number 3. This is the road design. So, doesn't make sense actually. Let's just do garden. The length of a rectangular garden is 4 meters greater than the width. The area of the garden is 96 meters square. All right. Find the length and the width. Maybe you guys should start first. Try first. Find the length and the width. Okay. So try it first. So I'm going to give you probably 5 minutes. And then we will do another type of word problem, which is just substituting the value, and then we're done. And we could start with the other one, the quadratic formula. Yeah. All right. Are you guys voting for the test to have the test on this Wednesday, right? Were you the one voting? Did we take a vote? Oh, okay. Okay. Good. So try to work on it, okay? So you have width, and then the length is 4 meters greater than. What does it mean, 4 meters greater than? X plus 4, yes. Good. Are you done? Leslie, you done? Are you guys done? Well, what is the length and what is the width?
Length after AW.
Yes, that's fine.
30 plus 4.
Mm-hmm.
And width
W, right? Width is W. Then, yes. So what's the equation? Yes. So W times W plus 4 is equal to 96. That's right. So what is W and what is... Okay, so why don't you work on it a few more minutes? Were you done? Okay, what was the answer? Right. Yeah, that's right. 8 and 12. Did everybody get 8 and 12? Okay, so let's do it. Yeah, because you guys are done. All right, so step 1. Do we need drawing for this? Yes, so let's draw it. Okay, so we have width and we have length. What do we know about the width? What do you want to call the width? X or W? X, okay, it's fine. What do you want? Then what happens to the length then if you call it X? Yes, so X plus 4. So X is the width. X plus 4 is the length. Good. All right. What do we know about the rectangle again? The area is 96 meters squared. Yes. Step 3, equation. So area is length times width. And we have the area to be 96 is equal to X plus 4 times X. Yes. So 96 is X squared plus 4. Then what? Yes, subtract 96. So step 4. Or actually here is step 4 because you're solving it. X squared plus 4x minus 96 is equal to 0. Factor 96. So you said 8 and 12? Yes. So x minus 8, x plus 12. Yes. So x is equal to 8 or x is equal to negative 12. Yes, that's right. So which one do we choose? 8. Why don't we choose negative 12? Yes. So width can't be negative. All right, good. So step 5. Yes. So width is 8 meters. What about the length? Yes. How do you get 12? Yeah, that's right. X plus 4. So this is your X. And this is your X plus 4. Right? Okay, good. Are we okay so far? Yep. Okay. Easy? If I ask you this on the exam, you can do it? Of course, right? Okay. So exam is Wednesday. Good. Now, let's do another one. Here you just have to substitute the value. Yeah. So the other application. Here you just substitute the value. So other application. All right. So let's see. Okay. So it talks about numbers of handshakes. So you just have to substitute the value. So the number of possible handshake each within a group of n people is given by h is equal to half times n squared minus n. All right. So the number of possible handshakes within a group of n people is given by h equals to half n squared minus n. So at a party, there are 25 people. How many handshakes are possible? So that's the question. So how are we going to answer this? Yes. So 25 is what? N or H? N, yes. So N is 25. So what is H? H is half times 25 squared minus 25. All right. So H is half times, what is 25 squared? 625 minus 25, which is 600. So H is 300. That's it. So answer is number of possible handshakes. Handshake is 300. All right. Good. Yeah. Half times 600 is 300, right? What is half of 600? 300. Is it easy? Yes? Okay. Now, I'm going to do something else. This is a quadratic formula. Have you ever heard of it? X equals negative b plus or minus b squared minus 4ac all over 2a? You have heard of it. Okay, so let's discuss that. Yeah, I'm done with chapter 5. So today you're going to download your sample test, right? And you're going to work on it. And tomorrow you have questions, you can ask. Yeah? Okay, and the test is on Wednesday. All right. Let's see. We'll see. So I'm done with this. Let me save this. So file, save as. All right. 5.8 application. Yes. We save it as 5.8 applications. Okay. Good. So let's close this first. And I am actually done with 5.8 solving applications. So the next one, we're going to talk about the quadratic formula, actually. Yeah. So we will talk about quadratic formula. And on your homework, it's going to show up as 5 supplements. But it's not going to be included on the test. It will be included on the next test. Yeah. So it's not going to be included in this test, but it will be included on the next test. All right. Anyway, let's start with 5 supplement, which is the quadratic formula. So let me share the desktop, and let's start a new section. So I'm going to label it as 5.s. The 5s is 5 supplement. Let me write down supplement. This is the quadratic formula. Why do I need quadratic formula? Sometimes I cannot factor or it's too big. So that's why we need this quadratic formula. Now, I need you to learn about perfect square first. Yeah. So let's talk about perfect square. Before we talk about quadratic formula, we have to be able to, for example, simplify what is square root of 12. Yeah. So we're going to talk a little bit more slowly and start with square root, perfect square. So give me a list of perfect square. So the goal is we could simplify expression under square root. What is 1 square? 1. What is 2 square? 4. What is 3 square? 9. Continue. 16, 25, 36, 49, 64, 81, 100. And after 100, there are a few more. What is 11 square? Yes. What is 12 square? 144. What is 13 square? 169. What is 14 square? 196. And then the thing you have to probably memorize is 15 square is 225, and 25 square, which is 625. Also, 24 square, which is 576. Yeah. So I think all the way up to 100 you already memorized, right? Is that true or not? Not really, but you are going to. Yeah. So it's easier if you memorize. Okay. So now, how do we simplify square root? So the first thing that we were going to do is list all the perfect squares. So that's A, that's our goal. So the second thing that we're going to do is simplifying square roots. So it's just square roots. We're not talking about cube roots or anything like that. Simplifying square roots. All right. Yeah. So to simplify square roots, factor out the largest perfect square. From the radicand. So by the way, this is called a radical sign. So this is radical sign. Yeah. And in this case, this is the square root. It signifies square root. Now whatever is inside here, we call it the radicand. All right. So the number under the square root is the radicand. Yeah. So, for example, if I ask you, what is square root of 25? 5. Good. Why? Why is it 5? Because 5 squared is 25. Yes. What is square root of 144? What is square root of 144? Yeah. What is square root of 144? 12. Why? Because 12 squared is 144. What is square root of 576? 24. Why? Because 24 squared is 576. All right. Now we're talking a little bit different. We're going to simplify something else. Okay. Are you guys ready? Now, what about if I want to simplify square root of 50? And let's simplify, for example, square root of 12. Or if I want to simplify square root of, let's see, what is it, 108? Or square root of 20. So I need to factor out the largest perfect square from 50. And what is that? Can I say 5 and 10? No, why not? Because 5 is not a perfect square. What about 10? No. So what is square root of 50? Square root of, what is it? 25 times 2. Yes. So 50 is 25 times 2. Right? Or I could write it like this. Square root of 25 times square root of 2. What is square root of 25? 5. So this is 5 square root of 2. Okay. Yay or nay? Yay. So you need to factor out a perfect square. It has to be a perfect square. Why? Because otherwise, it cannot get out of the square root like this. Square root of 25 is 5. I need a perfect square. Yeah, it has to be a perfect square. Yeah, because otherwise it doesn't get out of the square root. Now, what about square root of 12? 4 and 3? Okay. 4 times 3. So I don't have to write this separately. What is square root of 4? 2. Square root of 3. All right. So again, I need to factor out what? Perfect square. The largest perfect square. From our list, remember? We have a list. Now, what about 108? What's it? 9? 9 is a perfect square? Yes. So 9 times, well, but it's not the largest, is it? Because 12 is not a perfect square. So you need to do the largest. Because if I say, look at this, if I say 9 times 12, then you say, oh, this is 3 square root of 12, then what am I supposed to do with 12? Yeah, so but 9 is not the largest perfect square from 108. So what's the largest perfect square I could factor out from 108? So 9, and then the next one is 16, right? And then the next one's 25, and then, what is it, 49. So what? 18? 36? Is 36 factorable from, can you factor 36 from 108? Yes, so that's the largest perfect square. So what, 36 times 3? Yes. Does the 36 go out? Yes, when it gets out, it becomes 6. So 6 square root of 3. How come the 3 has to stay under the square root? Well, no, it's not a perfect square. Yeah, so only perfect square can get out. All right, so this is the perfect square. So perfect square. All right, square root of 20. What is square root of 20? What times what? 4 times 5? Yes. So the 4 is the perfect square, right? So this is the perfect square. What is square root of 4? 2. So what about the 5? Stays inside. So 2 square root of 5. Doable? But it has to be the largest perfect square, right? Not just any perfect square, but has to be the largest perfect square. Now let's talk about the quadratic formula. Oh, we did a lot today. So this is C. the quadratic formula. Na, 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 na. You know the song? Na, 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 na. Yes, no? Up goes the weasel. Na, 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 na. All over 2A. Well, why am I singing here? I mean,
You like the math version?
that's the math version. The quadratic formula is negative b plus or minus the square root. Remember that? B squared minus 4ac all over 2a. Well, I'll pull it up from YouTube, so you guys could hear it. Yeah. Okay. Wait. Let me do this first. Yes. No, it's going to take 3 minutes. So the quadratic formula. So remember. So just say I have these. So yeah. So extra credit for those who want to sing it. So suppose you have x squared minus 5x plus 3 is equal to 0. Can you factor this? So is it factorable? No, right? Okay, try to factor this. Can you? Is it factorable? No, this is not factorable. So this is when we should use the quadratic formula. Yeah, so quadratic formula works for all. So use the quadratic formula. So what is the quadratic formula? All right, formula. So this is the formula. The solution of ax squared plus bx plus c equals 0. So this is the standard form. Make sure before we use the quadratic formula, everything is standard form. Is given by, is given by x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So this is called the quadratic formula. So what do you have to notice here is that the equation here has to be called what? What do we call this type of equation? Quadratic equation in what? Standard form. Yes, meaning one side is 0. Yes. So note, equation must be in standard form. In standard form. Quadratic equation. So the quadratic equation must be in standard form. Yeah. Okay, so let's pull up the song. Unless anybody wants to sing it. That's the Pop Goes the Weasel. So no, I'm not going to sing it. I'm going to pull it up in YouTube. YouTube quadratic here. Because I played it for my math 125. Get ready, get ready. Oh, no sound? Hold on. Okay, hold on. Okay, that's cute. Okay. Get ready. Okay. Oh my gosh, okay. Hold on. This is one direction. No, I don't like that. I like the Pop Goes the Weasel. Yes. Okay, get ready. Are you ready? Wait. Okay, so this is the quadratic formula song. Do you remember it? No? Oh, why not? The quad, oh no, not this one. No, I don't like it. This one, this one. Okay, one more time, okay? So who wants to sing tomorrow? Yes? Do you remember this? Memorize this? Can you sing it? Yeah? So what's important here? Oh, let me cancel this. What's important here is what is this? What is this? Sorry. So what's important here is negative b plus or minus. Let me just go back here. Sorry. Look at this. Negative b plus or minus square root of b squared minus 4ac. And then what did they say on the last sentence? All over 2a. So what it means is you can't do it. You cannot write it like this. Square root of b squared minus 4ac and then over 2a. What's wrong with this? Yeah, it has to be what? All over 2a. Yeah, okay. So you gotta remember the song. Yeah. Now, should we try one? Should we try for this? Yeah, we still have 8 minutes. Let's try it. No. Okay, so do it. Kahoot. What's Kahoot? Yeah, I do. I was going to prepare that. Yes. Okay, so for example, solve using the quadratic formula. The quadratic formula. All right. So solve using the quadratic formula. So what was that before we were going to do? X squared, what, minus 5x plus 3 is equal to 0? Okay, so how are we going to solve this? Right, so what is equals to negative b? X equals, right? X equals negative b plus or minus square root of b squared minus 4ac and then all over 2 times a. So that's the formula. So we're going to write it again and again and again. Remember, it's all over 2a. Yeah. Do I know what negative b is? What is negative b? 5. No, negative of negative 5, so it is 5. Plus or minus. Why is it plus or minus? Because there are two answers. One is plus, the other one is minus. Yes. Square root of b squared. What is b squared? 25 minus 4 times 1 times 3. And then all over 2 times 1. 2 times 1 is 2. Yes. So x is 5 plus or minus square root of, what is it? 25 minus 12. What is 25 minus 12? 13? Yes. Divided by 2. Now, can I simplify square root of 13? Yes. What and what? Can I factor out a perfect square from 13? No. So that's it. So I have to answer. Yes. What are the answers? 5 plus square root of 13 divided by 2. Or x is 5 minus square root of 13 divided by 2. I think you could do plus or minus now. So you could, yes, so you could leave this in FXL. 5 plus or minus square root of 13 divided by 2. Now, can we get an approximate value? This is an exact answer, but can we get an approximate value? What is it approximately? So we're going to use calculator, right? Okay. Now, usually we will just deal with the exact answer, but I really want you to find the approximate value. Yeah? So what's the approximate value here? Let me see. So 5 5 plus square root of 13 equals, and then divided by 2. So what's my answer approximately? 4.303. And what about the other one? 5 minus square root of 13 divided by 2. So what's the answer? 0.697? All right, approximately. Not really, but I just like you to know, oh, this is approximately 4 and this is approximately 0.7. Yeah. Should we do one more? No, we still have 4 minutes. Okay, tomorrow. So tomorrow we will finish, yeah, the quadratic formula. And what else do you have to do? Kahoot? No. Sample test. Yeah, sample test, okay? All right, chapter 5, sample test. Am I going to include this in your sample test? No, so it's going to be on the next test, chapter 6. Yes? All the homework that's due on Wednesday is 5.8 and the supplement. Yeah, the 5.s. Yes. Yeah. And should I reopen your quizzes? Okay. So let me see, and then I will send you an email. Okay. All right. Have a good one. Hi, Leslie. Let me close this first. I'll answer your question. Thank you. Okay, so I'm done with. I'm not done with quadratic formula. We will continue tomorrow. Yeah.